Morning, everybody. Or hello. It's morning for me. It might not be morning for you, but I know this lesson says 13.4, but it's 13.3 for us. Okay. I just skipped 13.3 because I didn't think it was something you really needed to know. Today we're going to be talking about central angles and their arcs. An arc, ARC, an arc is a curved line drawn between 2 points along a circle. Okay? So here, right here, you have an arc, AB. Okay? And when you write that arc, or when you read it, you're going to see it written this way, arc AB, like that, with a little, like a frown on top of it, showing that it's not a segment, it's an arc. Okay, so it's curved. A central angle is an angle whose vertex is at the center of the circle. That's what we're going to focus on today. Angles whose vertex is at the center of the circle. And then an intercepted arc is the arc that's formed when the segments, which are radii, intersect the circle and create an arc. So in this example, okay, we have a radius and another radius meeting at the center point P, forming a central angle APB or BPA. Okay, that's the central angle. The central angle's in here. Okay, the intercepted arc is the arc from A to, I will not make it pink, from A to B, like that. That is the inscribed arc. Okay, where does the angle cut into the circle? Okay, now we call that a minor arc because it's formed by an angle less than 180 degrees, and it's easy way to remember. It's the quickest way from A to B is minor arc AB. And we really don't even say the word minor. It's left off. Anytime we say an arc, we're assuming it's our minor arc. What is the major arc? Well, let's look over here, focus in the pink section for a minute over here. This is formed by an angle that is greater than 180 degrees. It's called a reflex angle. It's really big, okay? It's the rest of the way around point P, all right? And it cuts into the circle from A through C all the way around to B. So you don't call it arc AB because arc AB would be this one. So if you're talking about the long way from A to B, it's either called major arc AB, or you say it's A to B going through C. Okay? And all the way around the circle is 360 degrees. So if you know what this arc is, you could find that arc. We'll talk about that in a second. Okay, this is the same thing with the major arcs, minor arcs. You can look that over again. And a semicircle. This segment, EG, is a diameter, which is going, how do I know? Because it's going through the center of the circle. It's a chord. A chord is a line segment in a circle. Okay, and the longest possible one goes through the center. It's called the diameter. Now that diameter is cutting the circle in half. So its measure of the angle is 180 degrees, right? The angle there is 180 degrees because it's a straight line. Here it's not 180 degrees because it's not a straight line. ABC is not a line. It's cutting the circle in half, giving you a 180 degrees on this side and 180 degrees on this side, which totals to your 360. Okay, so the first thing you're charged with is finding out what is the relationship between the measure of the central angle and its intercepted arc. You can use a protractor to measure an arc of a circle, and you can also use a protractor to measure the given central angles. You can measure an angle, obviously, with a protractor. So let me do one example on this, and you can finish it. All right, central angle BAC. So the first thing we have to do is find that. B to A to C. Okay, from B to A to C, how far is the protractor open? All right, so we look here. Now you'll notice two numbers when you use a protractor. We're starting at 0 here. We don't want to start at 180. We're starting at 0. So it's 10, 20, 30. Whoops, I did that too long. Got to do it quicker. 10, 20, 30, 40. This angle is 40 degrees. And the arc is 40 degrees. I think you're quickly going to see a relationship between them. Now I'm going to erase my highlight and my mark so I'm fresh when I start the next one. I'm not going to do all of these for you, but I just want to show you how they overlap. So let's do BAE. Just highlight BAE. B to A to E. B to A to E. Okay, now you don't have to count each time. You could just look at the numbers that are here. Right? 120 and 60. If I'm going in this angle, that has to be obtuse, more than 90, because 90 would be straight up here. So it would have to be the 120, using the top numbers when you're starting over here. Okay, so it would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. If you were measuring FAE, you would not get 120 because you'd be starting here using the lower numbers and get 60. Okay, so you can fill this in and you can answer this question. The measure of the central angle is blank, the measure of the intercepted arc. What do you think it is? The measure of the central angle and the arc. How far is the arc open in degrees, and what is the angle open? And I think by this diagram you're going to see that they're the same. Okay, so central angle equals the intercepted arc, and a major arc and a minor arc formed by the same central angle have to equal 360. So if you know that this angle is 50 and this arc is 50, then you could get the major arc by doing 360 minus 50. Here's some problems for you to work on. Understanding this, showing your understanding of this, okay? In number 5, it says, assume lines which appear to be diameters are actually diameters. If they go through the center point, if a chord, that's a line segment in a circle, goes through the center point, it is a diameter. So in this case, they're not named, but both of these segments are diameters. What do diameters do? They split the circle in half. So you're going to know when you do this problem that from here to here is 180. Now you'll be able to figure out the other things. And from here to, and the other way also is 180. And also, wait a second, you can even do, why did I do that? You can even do it this way. Here to here is 180, right? So the whole arc, I don't want to put the 180 here because I don't want you to think. That central angle is 140, so that intercepted arc has to be 140. And together, from here all the way around to here is 180. So you can solve for x. Okay? Now, this kind of question I'm just going to work on with you now because this is a ratio question from algebra. I told you earlier in the year that every time these come up, I will put them on so you can see, and this is a very popular place to see a ratio question again. So it's saying the arcs are in a ratio of 4 to 5 to 6. Now, remember the arcs, when you have a ratio, it's done in respectively, so that whatever your first arc is, that goes with the first number. And your second arc goes with the second number, and your third arc goes with the third number. So arc CB would go with the 4. Okay? And arc BA would go with the 5, and arc AC would go with the 6. All right, now, you will notice that 4, 5, and 6 do not add up to 180. Because in ratios, remember, the greatest common factor has been removed. You have to put it back in. Put it back in. How am I going to put it back in? I don't know what to put in. What is it? Is it 2? Is it 4? Is it 6? We don't know what it is. So we're going to put in the unknown x. Put x back in, and you end up with 4x, 5x, and 6x. Now, we've done this a couple of times, so I'm hoping you're getting better at this. This is a skill from algebra that you need in your future math classes and tests. Okay, so now we can say, all right, 4x plus 5x plus 6x equals 360. All the way around the circle is 360. Now that adds up to 15x equals 360. Can you find x? Of course you can. You're champions at this. Divide by 15, and x equals 360 divided by 15, which is 24. Okay? Now, you're going to put that back in to the ratio values. So, arc CB is 4x, so it's 4 times 24. Figure that out. And arc BA is 5 times x, which is 5 times 24. Figure that out. And arc AC is 6 times x, which is 6 times 24. Why did I put a 25 there? That's wrong. Caught my own mistake before you did. Okay, so that you will be able to understand. All right, a summary. Quick summary. You ready? Central angle has vertex at the center. That's why it's called a central angle. Okay, and it is equal to its intercepted arc. That's spelled wrong. Sorry. Okay, that's prime summary. Also, the other thing we learned were all the way around the circle is 360. Okay. Halfway around is 180 if this is a diameter. Right? We learned about the minor arc and the major arc. Okay? So I'm hoping this is enough information to get you to finish all these. There's no other assignment. This is it for right now. Go through this and fill it in, and email me any questions or problems you may have. Have a great day. I miss you.